Good day, Math Wizards! I am Xavier Francis Asicol, and for today we're going to have a tutorial video about the application of antiderivative or integral, specifically the constant of integration. But before we're going to proceed to the problem, let me first explain to you the meaning of antiderivative or integration or integral. So antiderivative is completely the opposite of derivative, wherein derivative you have a certain function, and with that certain function you're going to find the derivative of it through a process, a formula, given constant formula. Anyway, and that derivative of a certain function, that is now the constant derivative. Meanwhile, in antiderivative, that certain derivative of a function, if you're going to transform it to its original form, that is the process of antiderivative or integration. So that's the concept of the two. So what are we waiting for? Let us proceed to our problem. In 3, 2... Here is the problem. Find the equation describing the motion of an object moving along the straight line where the acceleration is constantly 4 meters per second squared when the velocity at time t is equals to 5 seconds is 12 meters per second, and when the object has traveled 80 meters from the region at 10 seconds. So first things first, we're going to identify the formula in order to solve the in order to find the integral of this acceleration. So I'm going to present to you a formula. dv over dt is equals to acceleration. This is read as the derivative of velocity with respect to time t is equals to the acceleration, and we're going to derive this so that dv will only be the one left on the left side. dv is equals to dv a dt. So I did multiply the dt to the whole equation, so dt now is in the right side of the equation. And then in order to end up with the integral of the velocity, we're going to make this d to an integral which a dt. So this is now the process, this is now the formula in order to get the the velocity in a given value of acceleration. So in the problem, the value of the acceleration is 4 meters per second squared. So we're going to write this as v is equals to integration of 4 dt, and just follow me. 4 integration of dt, so 4 times t plus c is equals to multiply the 2 4t plus c. So this is now the formula, this is now the equation that will represent the velocity of this problem, of this. So next step that we will do, since we have the given time for the velocity which is equals to 5 seconds, and the velocity itself is equals to 12 meters per second, so we're going to substitute these values to the equation of velocity. 12, which is the velocity, and for time is equals to 5 seconds, 5 plus c. So do the equation. 12 times equals to 20 plus c, so transpose 20, so c now will be negative 8. That's the value of the constant for the velocity. So we're going to rewrite it as v is equals to 4t minus 8. That's it. So the second thing that we'll do is we're going to find the integration of the given equation of velocity. So the displacement with respect to time is equals to velocity, and then we're going to multiply the whole equation by dt. So v dt, and so s integration of v dt. So this is now the formula in order to get the antiderivative of the velocity. So as we're just going to substitute this equation 48 and dt, and we're going to segue the two variables 40 dt minus 8 dt. So s is equals to 4 t dt minus 8 dt. So s is to just do the equation, or no. So 40 now 4t squared over 2 minus 8t plus c. So we're going to simplify this equation. S is equals to 4 divided by 2, so 2t squared minus 8t plus c. So this is now the equation that will represent the displacement of this problem. So as you can see, the value of our constant is unknown, so we're going to find it through the given values of the displacement, which is 80 meters 80 equals to 2, and time 10 seconds, 10 to the power of 2 minus 8 times 10 plus c. So 80 is equals to 2 times 100 minus 80 plus c. So just transpose the coefficients, and c is equals to negative 200 plus 160. So c now is equals to negative 40. So that's the value of our c. And since now we have the value for the constant of our displacement, we're going to substitute it, so that we're going to find we'll be going to find out if what is really the equation for the displacement. So s is equals to, copy this, 2t squared minus 8t minus our constant minus 4t. Yeah, so this is now the answer for this problem. So that's it for our constant of integration, application of constant of integration.